So we've reached everyone's favorite, Module 5. Um, some of the things that I'm going to go over today are the sum and difference formulas, as well as verifying trig identities and solving a trig equation. Now, for the first problem, note that I am asking for the cosine of x minus 3 pi over 2. I'm going to change this a little bit into, instead of simplified, find the exact value. So what happens when they ask you to find the exact value? That means that they're asking for the fraction form. So in case x was just an angle as well, you can't just punch it into your calculator and come up with a decimal. The exact value means the fraction form. If you look here, this is your angle. You have two angles being subtracted. So being subtracted means you're going to apply the difference formula. So note that you are given the difference formula for cosine, and they could write it as a minus b or x minus y, depending on which part you're looking at, textbook or your reference sheet. So I'm going to stick with a minus b. When you have two angles being subtracted, the formula is cosine a cosine b plus. So notice in cosine sum and difference formula, the operation is always opposite in the expression. So plus sine A, sine B. And then from here, in my problem, I'm given A as x and B, my second angle, is 3 pi over 2. Don't worry about the minus sign because, again, it's already taken care of in the difference formula. That's why we have a sum and a difference. So don't count it as negative 3 pi over 2. So from here, I'm going to take cosine. Instead of A, I'll write x, and then times cosine of B, which is 3 pi over 2, plus sine of x times sine of 3 pi over 2. From here, PEMDAS. We multiply before we add. Now, you're not reinventing this wheel. You don't know what x is. Bring it down. But on the unit circle, you do know the cosine of 3 pi over 2. So if you look at the unit circle at angle 3 pi over 2, which is also 270 degrees, the x is always the cosine value. And at that point, it's going to be, or at that angle, it's going to be 0. So cosine times 0 would give me 0. Anything times 0 is 0. And then drop down the plus sign. You have sine of x. Again, you don't know what the angle x is, so we bring that down. And it's being multiplied to the sine of 3 pi over 2. Now the sine is the y value, and at 3 pi over 2, or 270 degrees, the sine value there is negative 1. So negative 1 times sine of x gives me negative sine of x. And for my final part, I have 0 minus sine of x, which is just negative sine of x. For the next problem, I'm simplifying. So when you're verifying trig identities or simplifying them in this case, ideally you'd want to change everything to the same trig function. So you'll look at your identities, meaning your Pythagorean reciprocal quotient identities, and you'll see if cosecant and tangent have anything in common. Looking at the identities, they don't have anything directly in common. So if it's not possible, you change everything in terms of sine and cosine. Now that I can do, because if you look at the reciprocal function, I can change cosecant into 1 over sine of x. And I can change tangent under the quotient identity into sine over cosine. So from there, you apply the algebra. So meaning in this case, you have two fractions being multiplied to each other, so you can multiply. We do multiply fractions straight across. You can also cross reduce before multiplying straight across, because if you look, the signs will divide out. And I'll be left with 1 over cosine x. Not quite done yet, because if you look under the reciprocal identities, what is 1 over cosine x? Well, that would be secant x. Final answer. And for the third problem, you're solving for x. Now, this is the ideal situation. all of the trig functions are the same. So it's the ideal equation because if you can't see what to do here, you can always give yourself an algebra point of view, meaning you can change everything that says sine into just x. So from there, I can change this equation into 2x squared minus x minus 1 equals 0. This is just a quadratic equation. You can use factoring, quadratic formula, completing the square, anything that you preferred in Algebra 2 to solve for x. So in this case, I prefer to factor. So to factor, I multiply first times last, 2 times negative 1. I need two numbers that multiply to be negative 2 and add up to be the middle number, which is negative 1. So those two numbers are going to be negative 2 and 1. Negative 2 times 1 does multiply to be negative 2, and negative 2 plus 1 does add up to be 1. So over each one of those numbers, I always put the leading coefficient and x. So I'm going to put 2x over each one of them. And what do I do from here? I reduce. So this would give me x over negative 1. And this one would just stay 2x over 1. So this actually represents my two parentheses. So x minus 1, the first fraction is the first parentheses, and 2x plus 1. Remember that it equals 0. So if it's factored and the other side equals to 0, you set each parentheses equal to 0. So I'm out of room, so I'm going to move it all the way up here instead. So from that last line, x minus 1 times 2x plus 1 equals 0. If I set each one of these parentheses equal to 0 and solve for x, I'll get x equals 1. And for the second parentheses, if I set it equal to 0 and solve for x, I'll get x equals negative 1/2. From here, I'm going to change it back. Remember, you changed everything that said sine into x. So now that you solved for x, change it back. So sine of x equals 1, and sine of x equals negative 1/2. So what I'm doing here is I'm solving for x. I'm solving for the angle where sine is equal to 1. So if you look on the unit circle, where does sine equal to 1? It's at pi over 2. And then here, you're looking for everything in the unit circle where sine is equal to negative 1/2. So where would sine equal to negative 1/2? That would be anything that's over 4, or sorry, over 6. So remember, in the first and second quadrant, sine is positive. So the two angles are going to be in quadrants 3 and 4. So that would be 7 pi over 6 and 11 pi over 6. Those are your three values. I hope this helps.